CNC milling and machining centers. The basic milling function, the actual cutting or removal of material from a workpiece, is the same with CNC milling as with manual milling. The only difference is that the movement of the tool and the workpiece is controlled by drive motors and CNC controls. A CNC milling machine looks much like a manual milling machine. There will be a CNC control that will look much like a DRO or a digital readout, like the one you saw in the previous video. The program, in other words, the set of electronic instructions that the control will use to tell the machine exactly what to do to produce a part, can be entered directly into the control on the machine. Or, as is often the case, the program can be created on a computer at another location and then sent to the CNC milling machine electronically. There is sometimes a bit of confusion about CNC milling machines and CNC machining centers, and the terms are often used interchangeably. But they do the same work. Machining centers, like the one you see here, are basically CNC milling machines with some added features. These added features are a tool changer, an enclosure or cabinet, a coolant pump and reservoir, and a chip conveyor. Machining centers might have some or all of these features, but all will have a tool changer. That is the primary feature that distinguishes a machining center from a CNC milling machine. The tool changer, as you see here, adds a great deal of efficiency and productivity to the milling process. It allows a machine operator to set up several tools in advance of running a job, allowing the machine to run several operations in sequence on a quantity of parts without the operator changing tools manually between each operation. It is virtually always the case that multiple operations are required to make any part. For example, a part might require that a workpiece be qualified to size using a fly cutter, then have several holes drilled in different sizes, then have angles or slots milled along the length of the part. Finally, perhaps some of the holes need to be tapped for threads. A machining center could be set up to do all of these operations without the operator having to do anything but load the workpiece, wait for the part to be made, then unload the finished part and load a new workpiece or blank. Typically, a machine operator will do other things while a part is being made, like inspect the part for dimensions, making sure they are within specified tolerances, and cleaning and packaging the part. With machining centers, much more time is spent in setting up a job, including programming the commands that the machine will use to make the part and loading the tools that will be used. Compared to a manual or standard CNC milling machine, machining centers can sometimes make parts in a small fraction of the time. Since the time required to program and set up a job on a machining center is considerable, these machines are typically used to make larger quantities of parts to justify the time required to set up a job. In some cases, manual machines can produce parts as efficiently as a CNC machine. It all depends on the shape of the part and the quantity being produced. It is common for machinists, when making metal parts, to use a coolant to minimize heat buildup and help tooling last longer. Coolant, normally a water-based liquid that might contain lubricants and anti-corrosion additives, is applied to the cutting area through a nozzle and floods the work area, keeping heat to a minimum. In most cases, plastic parts do not require coolant to be used, but there are exceptions. Some materials, especially those that are more crystalline or have fillers like glass, can generate significant heat when they are machined, and some machinists will opt to use a liquid coolant to minimize the heat created during machining. It is important to use coolants that are compatible with plastics to prevent a reaction in the material to the coolant. All of our engineering material suppliers have this information available. A chip conveyor is used to carry the chips, the material removed from a workpiece during machining, away from the work area. This is much more common with metal, since the metal chips are heavy and sink in the coolant reservoir that contains the coolant. The chip conveyor gathers the chips from the bottom of the reservoir and moves it to a collection area, typically a bin outside the machine. Plastic chips are light by comparison and float in a liquid if one is used, and can be difficult for a conveyor to efficiently handle, wet or dry. Plastics are notorious for clogging chip conveyors and coolant filters and screens. Therefore, most machinists choose not to use a chip conveyor when machining plastics, even if the machine is equipped with one. Chips are removed from the work area using compressed air if necessary. In conclusion, milling is milling. Every machine shop, whether a standalone shop or one that is part of a manufacturing operation, will be equipped a little differently. The nature of the work being done, the financial resources of the company, the materials being machined, and the long-term planning of the company all play into how they will equip the shop. A large standalone machine shop might have dozens of pieces of machining equipment made up of various types of machines, including manual and CNC and machining centers. A small family-run shop might do very well with one or two machines. We do business with both of these and everything in between. Next, let's take a look at a machine that shares many features with milling machines, the router. We will primarily focus on CNC routers, but we will touch on manual machines as well.